Good morning, good afternoon, or good evening, everyone. My name is Charles Turconoze. I am the product manager responsible for the 3D computational fluid dynamics suite Vectis at Realis Simulation. Welcome to this presentation of the new features introduced in Vectis by our first release of 2025. Our fluid product, Vectis, is a high-fidelity expert 3D CFD solution for tackling challenges in ICE design, thermal management, and general fluid systems. With the Vectis suite, our customers can accelerate virtual product development and take advantage of the latest R&D. Realis products put customers at the center of decision-making and deliver a personalized experience while minimizing their development cost. These 5 pillars of our product strategy firmly put the customer at the center of our product development. Today, it is my pleasure to give you an overview of how our new features can help you achieve your R&D and CA modeling objectives. In this presentation, I will give an overview of the numerous changes introduced in this release that enable advanced applications, enhance user experience, and streamline customer workflows. 3 themes, speed, robustness, and automation, are central to this release of Vectis. These themes can be found throughout the new features. We have introduced user-defined limits for a number of variables, including pressure, temperature, and turbulent viscosity ratio, to enable users to tailor the limit to the particular use case, therefore improving the robustness of every simulations, regardless of the application. The uniformity and maldistribution indices are now available as additional variables for surface sensors, typically inflow-outflow sensors, walls, and arbitrary surfaces. This enables to easily obtain additional insights into the flow behavior. A new thermal wall function, based on a proprietary blending of existing wall functions, enables an accurate heat flux modeling regardless of the near wall resolution, thereby significantly improving the accuracy of heat transfer predictions. Speed also features in both a speed-up of the spray solver, resulting in a 20% saving of computational time for rotary engine application, and up to 80% for spray-dominated flows, such as exhaust cooling. Speed also features in the export of surface mesh in R geometry, whose time was reduced by up to 90%. Our post-calculations, editing, and addition of new results in existing sessions are also much faster thanks to targeted enhancement. The grid-to-grid restart algorithm that enables the restart of a simulation on a different decomposition has been extended to rotary and to stroke engines, allowing a greater flexibility in the use of the available computational resources. The condition modifiers controls have been refined such that the user can now select which of the variables will be modified. This improves the workflows through a more efficient use of restarts, amongst other applications. The RViewer automation script that was introduced in the 2024.2 release has been extended to support additional options such as ISO volumes and user-defined expressions, thereby opening the possibility of more detailed and complex visualization. Seamless cooperation within teams is also a core focus at Realis Simulation, and the 2025.1 release introduces the possibility of exporting the session materials to a new library, potentially in a shared location, enabling easy access and reuse across organizations. Finally, I should mention 2 important licensing changes in this release. For desktop applications, we introduce Reprise License Manager as a replacement for FlexLM. This change, combined with the improved license configuration panel and support for user profiles, provides our users with better flexibility, allowing seamless usage of on-premises and cloud licensing options, as well as better management of multiple licenses. Towards the end of this presentation, I will also cover briefly other enhancements available with this release. If you have any questions about the features we cover or would like to know more about the other features, please reach out to us at support@realis-simulation.com. realis.com. Let us now dive deeper into the highlighted features to provide you with a better understanding on how they can help you enhance your CA workflows. Let us start with the improvement in heat flux modeling. Optimizing engine block performance requires precise thermal management as the combustion heat is dissipated through the various surfaces. Vessels plays a crucial role in this process by generating precise heat flux maps for FE analysis tools such as Realis FEARCE-Vulcan. One of the challenges in ice simulation is the large change of the Y+ values during the cycle, with an increase during compression, a sharp decrease as the flame propagates, and a subsequent increase during expansion. It is therefore challenging to obtain an accurate heat flux prediction, since well-established thermal wall functions, such as the unified or Handwrights formulations, have a narrow range of applicability and may lead to inaccuracies when used outside of it. At Realis, we recognized this challenge and introduced a new thermal wall function based on a proprietary blending of the unified and original Handwrights wall function, such that an accurate heat flux can be obtained regardless of the near wall resolution. This new blended wall function is accessible in the turbulence modeling edit panel through the Handwrights temperature wall function and supersedes the original formulation. The image on the left shows here the validation of the new wall function on the well-known GM Pancake engine. This single-cylinder research engine operates at 1500 RPM with a lean propane premix charge and 13% EGR dilution. 4 heat probes, shown here, are positioned on the flame face at increasing radius from the centrally mounted spark plug. The RTZFG framework, coupled with the DPIK spark model, is used for the computations on 4 different grids shown on the right, with Y+ values on the flame face ranging at the start of combustion from 7 to 90. The first grid is a Cartesian grid generated with Realis vMesh, while the 3 others are StarCCM plus grids with prism layers of various thicknesses. The results obtained with the baseline wall functions, the unified with the solid line and the Handwrights with the dotted line, shows that the unified wall functions are accurate for low Y+ grid, but underpredict the heat flux for coarser grids. The opposite is true for Handwrights. This final image shows the prediction obtained with the new wall function, demonstrating that despite very different near-wall grid resolutions, the results obtained are very consistent and compare favorably with the experimental measurements. The reuse of simulation results is paramount to the efficiency of computational workflows. From the calibration of engine results, spray and combustion for example, to the computation of different operating conditions for fluid systems in which using a previously converged simulation may significantly reduce the required computational cost of subsequent iterations. Efficiently reusing restart files rests on the possibility of selectively modifying the flow field as required by the new calculation. In the 2025.1 release, we introduced this possibility with the modification of the GUI panel and solver behavior that allows the user to selectively enable or disable the variables to be modified by the condition modifier. The image on the left shows the new GUI where each variable is now associated with a checkbox, which is enabled by default, indicating whether the variable modification will be applied or not. The first application here presents a gasoline engine with a restart at intake valve closing, where the pressure and temperature are modified, and therefore the trapped mass, while the mixing and velocity field are left unchanged. The second example shows a diesel engine where the swirl is modified at the start of injection, for example for the analysis of the combustion sensitivity to the swirl number. RPost plays a crucial role in analyzing and post-processing Vectis results. Every Vectis user, regardless of the application, interacts regularly with RPost with their own workflow. In this release, 2 key improvements are introduced to accelerate workflows to a reduction of the operations required to obtain the desired result. The first of these changes regards the calculation window that has been improved, allowing users to edit, move, and reorder source curves, thus providing a better controls of a calculation. The video demonstrates a new feature through the presentation of a curve defined as the sum of the heat fluxes on three different surfaces, liner, piston, and flame face. A new report file is opened, and the curves are cross-plotted using the Add Result Wizard window. The calculated curve is not automatically cross-plotted, but is copied manually. The copied calculated curve still references the original source curves, which are then edited to point to the curves of the newly imported file, using the new Edit button. This updates the calculated curve. Finally, a new calculated curve measuring the difference between the heat flux sums is added to the plot. Using the new Move Up and Move Down buttons to reorder the source curves in the calculation seamlessly switches before file 1 minus file 2 to file 2 minus file 1. The second key improvement brought about in our post concerns the cross-plotting capability. In CFD post-processing, one of the most repeated operations is to cross-plot results with those of the previous computation in the case of a restarted run. In this case, the desired behavior is that the cross-plotted curves share the same style as the source ones to maintain readability and consistency. Up to the 2025.1 release, this was not possible and led to potentially lengthy operations of harmonizing curve styles over numerous pages and plots, especially in the case of complex templates. This release introduced a new option in the Add Result Wizard window by which the cross-plotted curves may inherit the style of the source ones. This reduces the addition of restarted report files to a single-click operation. This improvement is demonstrated with a simple session containing 2 pages for cylinder statistics and computation residuals. All the curves have different styles. A second report file corresponding to the continuation of the first computation is added, and the user chooses to add the results to the existing plot. The new checkbox Match Style is selected and the source file validated before pressing OK. New curves have been added on every plot, with the style matching that of the original one in a single operation. One of the core activities of CFD engineers lies in the communication of the simulation results and the engineering decisions stemming from these results. In particular, the analysis of the flow patterns is an important step and requires the export of numerous flow visualizations using various techniques such as isosurface, isovolume, slices, streamlines, etc. A key consideration in the export of images is the possibility of maintaining the style consistent to facilitate the comparison and analysis. This step often requires lengthy and repeated operation. The time spent generating images can be greatly reduced by leveraging the scripting interfaces of RViewer, both using the RBF or Python format. However, Realis recognizes that not all CFD teams have the time to develop and maintain post-processing scripts for generating images of the computation. To this end, the automation of image generation was simplified as much as possible with the addition of a new script wrapping the RViewer Python interface using a simple JSON input file that controls the parameter of the image generation. To guide the use of this script, a new example has been added to the How-To section of the user manual. This release brings additional features to this wrapper, such as the user-defined expression and isovolumes, amongst others. We start here by showing the Vectis manual section that describes the input file structure, and a typical directory containing the various camera operations and the JSON input file is then shown before inspecting it. It is divided in various blocks defining the post file, user expressions, slices, plots, droplet plots, streamlines, etc., which are then combined in the various images to be produced. The script is then executed on the post file of a typical gasoline engine simulation, and the image generation proceeds with the loading of the post file and a loop over the various time steps, camera orientations, and images to be stored. After the script has completed, the produced images are inspected, showing the various plots such as spray, the velocity vector field, or the temperature isosurface. Seamless cooperation within teams is a core focus of Realis Simulation, where each release brings improvements to simplify shared workflows. In the 2025.1 release, users can export the session materials to a new user-defined library in any chosen directory. This enables the storage of material libraries in shared locations accessible for easy access and reuse across the organization. This feature is triggered by a new button in the main toolbar. So in this session, for example, we modify the material properties of water. The density, CP, and viscosities are modified before saving these changes to the session. The new feature is then used to export the material library to a new directory. The library can then be loaded in RDesk to be inspected using the material editor. A new empty Vectis session is then opened and a new fluid domain created. The new library is activated in the session, and the materials contained in it imported. Apart from these headline features, there is also a large number of smaller, but not less important improvements and corrections introduced to the Vectis toolchain in this release. The liquid component names are now synchronized in the various models required linking of liquid and gaseous components, so spray and wall film in particular, to simplify the setup of complex multi-component evaporation. The link between wall and wall sensors has been made persistent in the case where the triangulated file of the moving boundary is changed, but the boundary names remain identical. This facilitates the setup of parametric analysis where the moving boundary geometry is a parameter. A new passive scalar source option was introduced with the possibility of specifying the total rate irrespective of the volume chosen for the source by redistributing the rate over the cells included in the selected volume. This makes the source independent of the local grid refinement. Boundaries can now be selected simultaneously in the various sensors to speed up the setup of complex models. The missing PSD particle size distribution specification in the case of arbitrary surface injectors was added. The user programming interface was expanded to include the access to the cell zone array, which allows the simplification of the selection of cells and faces belonging to a specific zone. This is particularly useful in the case of ice applications, for initial conditions, tailored post-processing, etc. Finally, the coupling between the enthalpy and temperature in CPV tables was improved for the so-called frozen reactors at low enthalpy. This improves the convergence property of the computations during the expansion phase. In the pre- and post-processing tools, the following enhancements have been introduced. In RViewer, the auto-apply checkboxes in the Streamline edit panel were not accounted for. This has been corrected, enabling a faster streamlined setup. In RGeometry, the phase splitting tool has been extended such that the split is applied to the current selection of faces, or when none are selected, to the whole model. This provides users with a finer control over the resulting geometry. An issue resulting in the impossibility of selecting nodes, surface, or bodies when the zoom level was too high has also been resolved, making the pre-processing of complex models much easier. And finally, in Outpost, the reordering of source files is now possible. In the wider Realis ecosystems, some additional changes are also worth mentioning. In RFlame, the progress variable reaction rate tabulation was improved for lean high GR conditions, which improves the accuracy of the CPV tables in this condition. The installer now includes a connection diagnostic feature, which enables users to detect potential issues related to the organization's firewall and security features before installation. These proactive checks simplifies troubleshootings and help ensures a smooth installation process. As mentioned initially, the Reprise License Manager is now available and is the new default. Finally, the session comparison tool, introduced in the previous release, was further enhanced. Users can now adjust the tolerance level for comparing real values, view session item icons within the comparison tree, and select an open or recently used session file for comparison. Additionally, options are now housed in a collapsible area to maximize the screen space for different trees, and the comparison order can be easily swapped for greater flexibility. Finally, let us have a brief look back at the key features of the past two releases, which may be of interest to you. We have introduced additional improvements in the rotary engine modeling, accelerated significantly the laminar flame speed table generation through the use of MPI, introduced a new emission model for alcohol-rich fuels in collaboration with Logi. Our geometry was augmented with surface mesh editing tools to close holes, for example. In the user experience, the case table was extended to enable the plotting of the various parameters as a function of the case number. And as I mentioned earlier, a session comparison tool was introduced. In terms of workflow, the geometry configuration management enables the use of a single session for different geometries. RViewer automation script was introduced. And finally, the export of post files per zones in multi-zone calculation was made possible in Vsolve. I hope you have enjoyed this short introduction to the new features of this first release of 2025. Our team is here to provide more information about these features and help you adopt them to enhance your CA processes. If you have any questions, please contact us at support@realis-simulation.com. Thank you for your attention.